India found something on the lunar surface that nobody, not NASA, not Russia, not China, not Europe, had ever discovered before. Something that had been hiding in plain sight for billions of years. Something so unexpected, so strange, so quietly revolutionary that when the data came back to Earth, scientists had to sit with it for a moment just to make sure they were reading it correctly. You will not believe what India found on the moon. So stay right here. Stay until the very end. Because by the time this story's over, the way you think about space, about science, and about what a country with nothing to prove can accomplish will never be the same again. Right now, nations from every corner of this planet are pointing their rockets upward, pouring billions of dollars, and racing to reach one single place, the South Pole of the Moon. Because the future of human civilization, whether people ever truly live beyond this planet, may depend entirely on what is hiding in those lunar shadows. And right in the middle of this global race stands India, a country that carried its very first rocket on a bicycle through a small town in Kerala, a country that built its first satellite tracking station inside what used to be a public toilet. And yet, when every nation lined up to race to the moon's South Pole, India did not just show up. India arrived first. Let that sink in. The bicycle country, the toilet tracking station country. That country got to the moon's South Pole before anyone else in human history. But what did India actually find when it got there? That answer is far stranger and far more important than most people know. To understand what India found in 2023, you have to go back to 2009. Because India did not arrive at the moon's South Pole by accident, it arrived because of a map. In 2009, India launched Chandrayaan-1, a spacecraft sent to orbit the moon and study its surface. On board was a special instrument provided by NASA called the Moon Mineralogy Mapper, or M3. As Chandrayaan-1 circled the moon, M3 built a complete color-coded map of the entire lunar surface. Different colors showed different minerals. And then scientists saw the blue areas. At both poles of the moon, the map showed clear signatures of water and water-building minerals. It was the first real scientific evidence that the moon might hold meaningful amounts of water in its surface. Now, tiny traces of water had been found before. When Apollo astronauts brought back moon soil in the 1960s, researchers eventually found water molecules inside. But the amounts were almost impossibly small. To collect just 1 liter of water from that soil, you would need to process around 200 metric tons of it, roughly 15 fully loaded dump trucks, just for a single bottle of water. That is nowhere near enough to support a moon colony. But the blue areas on India's map suggested the poles could be different, that there might be water ice there in quantities that actually matter. From that moment, the moon's South Pole became the most wanted destination in space. NASA made plans. China made plans. Russia, Japan, and Europe all made plans. And India made plans too. But India would be the only one to actually get there. Getting to the moon's South Pole is genuinely, terrifyingly hard. Rough terrain, endless craters, and permanent darkness that never lifts. In recent years, American probes, a Russian Lunar probe, and 2 Japanese landers all attempted to reach the moon and crashed. Even India crashed in 2019 when Chandrayaan-2 lost communication in its final moments of descent. But 4 years later, India came back with Chandrayaan-3. There is a moment in the history of a nation that changes how that nation sees itself forever. For India, that moment happened on the 23rd of August, 2023. A spacecraft named Vikram, named after Vikram Sarabhai, the visionary man who started India's entire space program, descended through the void above the moon's South Pole and touched down safely on the surface. Not crashed. Touched down. Safely. Precisely. The country with the bicycle rocket. The country that launched its first satellite using Russian help because it had no other option. The country that built a tracking station in a toilet because there was nowhere else to put it. That country was the first to set foot, metaphorically speaking, on the most important and most difficult landing site in the history of lunar exploration. The specific location where Vikram touched down is a region that the Indian scientists named Shiv Shakti Point. It sits roughly 600 kilometers away from the actual geographic South Pole, on the near side of the moon, the side that always faces the Earth. The choice of that name carries weight. Shiv Shakti, strength and power. A name rooted in ancient Indian culture, planted now on another world entirely, and the world took notice. Global media outlets that had spent years either ignoring ISRO or quietly patronizing its ambitions suddenly found themselves reporting on India's achievement with a very different tone. The space agencies that had quietly assumed India would struggle were now watching their own missions still sitting on the ground, while India's rover began rolling across the lunar surface. But what did Vikram find? What did India discover on that ground that no one had ever touched before? This is where the story gets genuinely extraordinary. What you are about to hear is something that, depending on how deeply you sit with it, might just be the most unexpected discovery in modern space exploration. The moon is electric, not in a metaphorical sense, not in a "this is so exciting" sense. Literally, physically, measurably electric. Vikram, India's lander, detected an unusually high density of electrically charged particles moving across the surface of the moon. And as those particles move, they create tiny, rapid spikes of electrical energy on the surface. Tiny sparks. The moon is generating sparks. Now, where does this electricity come from? Two sources, as it turns out. The first and most significant source is the sun. During the 2-week-long lunar day, the moon's days are extraordinarily long compared to ours. The solar wind continuously deposits streams of charged particles onto the lunar surface. These particles do not just bounce off. They accumulate, slowly building up over time, layer by invisible layer. The second source is something even more surprising: the Earth itself. The Earth has a magnetic field. That magnetic field does an extraordinary job of protecting the surface of our planet from the constant stream of charged particles pouring out of the sun, what scientists call the solar wind. The magnetic field deflects those particles, pushes them around the planet, traps them in a vast region of space called the magnetosphere. But those particles have to go somewhere, and they do. On the opposite side of the Earth from the sun, all of that concentrated radiation gets released back into space in a long, distinctive tail shape. Scientists call it the magnetotail. Now here's the remarkable part. For approximately 5 days every single month, the moon passes directly through the Earth's magnetotail. And during those 5 days, the moon gets absolutely soaked in concentrated radiation that the Earth has been collecting from the sun. The result is a layer of electrically charged particles that extends roughly 100 kilometers above the lunar surface. It creates, and this is a phrase that requires a moment to fully absorb, it creates a thin lunar atmosphere. The moon has an atmosphere, not in the way Earth does, not in any way that a human being could breathe. It is approximately 1/1,000,000th the density of Earth's atmosphere. It is, in practical terms, almost a perfect vacuum. But it is there, and it is electric. Nobody had measured this directly from the surface before India's Vikram lander touched down at Shiv Shakti Point. NASA did not find this. Russia did not find this. China did not find this. India found this. And in finding it, Indian scientists handed the entire global scientific community a new piece of understanding about a world that humanity has been staring at for the entirety of its existence. The moon, that silent, silver companion that has hung above every human civilization that has ever existed, every empire that rose and fell, every war, every harvest, every prayer, every birth. The moon has been quietly crackling with electricity all along, and it took a lander named after an Indian visionary, built by an organization whose first rocket was carried on a bicycle, to finally detect it. The electricity was extraordinary, but India was not done. Vikram carried a scientific probe specifically designed to be pushed straight down into the lunar soil. Its job was simple in concept, but incredibly valuable in practice: to measure how temperature changes as you go deeper into the moon's surface. The surface temperature near the polar region, based on existing models and calculations, was expected to be somewhere between 20 and 30 degrees Celsius during the lunar day. That is what the scientists anticipated. What they actually found was 70 degrees Celsius. 70 degrees. Not 20, not 30, 70. The surface was dramatically hotter than anyone had predicted. That alone would have been a significant and publishable finding. But it was what happened next that truly surprised the scientific team back on Earth. As the probe was pushed downward, centimeter by centimeter, into the lunar soil, the temperature did not just gradually decrease the way you might expect. It plummeted. With each single centimeter of depth, the temperature dropped sharply and dramatically. By the time the probe reached a depth of just 10 centimeters, barely the length of an adult's finger, the temperature reading was negative 10 degrees Celsius, from 70 degrees at the surface to negative 10 degrees at 10 centimeters of depth, an 80-degree temperature difference across a distance shorter than a typical pencil. That is a level of thermal insulation that is genuinely extraordinary. What this tells scientists, what this confirms in a way that had previously only been theorized, is that the lunar soil, called regolith, is one of the most effective natural insulators ever measured anywhere. Just a thin layer of regolith, just a few centimeters of it, can block an astonishing amount of heat from passing through. And the implications of that for human beings who might someday want to live on the moon are enormous. If regolith is that effective as an insulator, it means that a habitat built under or within a layer of lunar soil would be protected, genuinely protected, from the brutal extremes of temperature and radiation that batter the surface of the moon every single day. The moon's surface temperature swings between approximately 120 degrees Celsius during the day and negative 130 degrees Celsius during the night. That is a swing of 250 degrees between day and night. No human being can survive that without protection. But regolith, the very dirt of the moon, could be that protection. India's probe confirmed it. India's probe essentially handed future moon colonists one of the most important pieces of engineering data they will ever need. That the moon's own soil can serve as the walls of the first human home on another world. And none of that was even the primary objective of Chandrayaan-3. Vikram's main mission, the reason the whole world was watching, was to find something else entirely. Water. After landing safely at Shiv Shakti Point, Vikram deployed a rover. The rover's name was Pragyan. In Sanskrit, Pragyan means wisdom, and this small, six-wheeled machine, controlled remotely by scientists sitting in a facility in Bengaluru, thousands of kilometers away, began slowly making its way across the surface of the moon. It was not fast, it was not large. It moved carefully and methodically across the rough regolith, guided by two cameras mounted at the front that transmitted images back to Earth, allowing the operators to see what the rover was seeing in real time. Pragyan eventually traveled approximately 100 meters from the landing site, a modest distance by any measure, but on the moon, in terrain that nobody had ever navigated before, it represented a genuine achievement. And along the way, Pragyan was analyzing everything it rolled over. The rover carried two scientific instruments, both designed to figure out the chemical composition of the material beneath its wheels. The first was an alpha particle X-ray spectrometer. This instrument works by directing radiation at the surface of the regolith and then carefully measuring how the particles bounce back. Different elements cause the particles to bounce back differently, which allows scientists to identify what those elements are. The second instrument was a laser-induced breakdown spectrometer. This one does something almost dramatic in its simplicity. It fires a laser at the regolith. The laser causes the material to emit a brief flash of light, and by analyzing the wavelengths of that light, scientists can determine precisely which elements and molecules are present in the sample. Together, these two instruments gave the team in Bengaluru an incredibly detailed chemical portrait of the lunar soil at the moon's South Pole region. A portrait that had never been painted before, because no rover had ever been there before. And what did Pragyan find? It found metals, aluminium, calcium, chromium, and titanium, all present in the regolith beneath its wheels. It found oxygen, which, as any space engineer will tell you, is always a welcome and encouraging discovery when you are thinking about the long-term habitability of a location. And then it found something that nobody expected at all: sulfur, a large amount of sulfur. Now, sulfur is not water. Sulfur is not a life support molecule in the way that oxygen or hydrogen are. But the presence of sulfur at the moon's south pole is deeply significant from a scientific standpoint, Because of what sulfur tells you about a place's history, sulfur is associated with volcanic activity. When you find sulfur on a rocky world, it is a signature that volcanic processes have been at work there. In fact, on the moon itself, the darker regions visible from Earth, those large, flat, dark patches that ancient cultures used to describe as the face or the rabbit on the moon, are recognized by scientists as ancient lava fields, solidified remnants of volcanic eruptions that happened billions of years ago. Those dark regions you would expect to be rich in sulfur, but the South Pole is not one of those dark volcanic regions. The South Pole sits in the lighter, older, more ancient highlands of the moon. And yet there was sulfur, right there. What this tells scientists is strikingly significant. It supports the idea already widely held, but now further evidenced that at some point in the moon's ancient past, the entire surface of the moon was molten. A global ocean of liquid rock, covering the whole body of the moon, volcanic in nature across its entire surface. The most popular theory for how this happened is both grand and violent. Approximately 4.5 billion years ago, scientists believe a rogue planet, a planetary body that has been named Theia, smashed into the early Earth in a collision of incomprehensible force. The impact released an enormous cloud of molten rock and metal into space. Over time, that cloud gathered itself together under the force of gravity, formed a sphere, cooled, and solidified. That is the moon, entirely volcanic in origin, entirely born from fire, and India's Pragyan rover, rolling quietly across the south pole of that moon, left a tiny trace of sulfur in its data that helps to confirm that ancient, fiery story. India found the chemical fingerprint of the moon's birth. But there is always a but. After all the extraordinary discoveries, the electric moon, the thermal insulation of the regolith, the sulfur, the metals, the oxygen after all of it, there remained the central question. The question that the whole world had been waiting for. The question that had driven billions of dollars of investment, years of engineering work, and some of the most technically ambitious space missions in history. Was there water? Pragyan was thorough. The rover covered 100 meters of lunar surface. It analyzed sample after sample. The two instruments on board were sensitive and sophisticated. The scientists monitoring everything from Bengaluru were diligent and careful. And the answer they found was no. Not a single detection of hydrogen. And without hydrogen, there cannot be H2O. Without hydrogen, there is no water. At the specific location where Chandrayaan-3 explored, the regolith did not contain detectable water. Now, this is a moment where it would be easy to frame India's mission as a failure, to say that the mission did not find what it was looking for, to allow that framing to overshadow everything else that was discovered. But that framing would be dishonest, and it would miss the entire point. Science does not only advance by finding what you were hoping to find. Science advances by finding the truth, whatever the truth turns out to be. A negative result, discovering that something is not where you thought it might be, is itself a profound and necessary piece of knowledge. And India's finding was backed up, very shortly afterward, by another mission. In 2024, China sent its Chang'e 6 probe to the south pole of the moon, not just to observe, but to physically scoop up material from the surface and return it to Earth for detailed laboratory analysis. The sample was brought back. Scientists studied it with instruments far more sensitive than anything that could be packed onto a rover. And their conclusion? No water in that soil either. So the question shifts. If there is no water lying around on the surface of the South Pole, which is what India's map from 2009 seemed to suggest might be possible, then where is the water? The science is extraordinary, but the human story behind it deserves a moment of its own, because this did not happen easily. This happened despite everything. ISRO was formalized in 1969 by Vikram Sarabhai, the same man whose name now sits on India's moon lander. Just 2 years later, Sarabhai was dead at 52. The vision behind the entire organization, gone. And yet the organization grieved and continued. It continued through rocket failures, through funding shortages, through a moment in the 1990s when the United States deliberately blocked Russia from sharing cryogenic engine technology with India, an attempt to slow India down. India's response was simple. India built the technology itself. No help, no shortcuts. Years of grinding, painstaking work until ISRO had its own cryogenic engines, among the most complex technology in all of rocketry. That pattern defines ISRO's entire history. Get blocked, get excluded, get left behind, and then quietly build it yourself anyway. When India sent its Mangalian mission to Mars in 2013, the total budget was $74 million. The Hollywood film The Martian, a fictional story about Mars, cost $108 million to make. India went to the actual Mars for less money than it costs to pretend to go to Mars in a movie. And India did it on the very first attempt. Only 4 space agencies have ever reached Mars successfully: America, the Soviet Union, Europe, and India. And of those 4, India is the only one that got it right first time. This is the organization that arrived first at the Moon's South Pole. And ISRO is not stopping. While scientists are still studying Chandrayaan-3's data, India is already planning its next moves. Chandrayaan-1 will send an Indian spacecraft to Venus. Chandrayaan-4 will return to the Moon, not just to land, but to collect lunar soil and bring it physically back to Earth, something only a tiny number of nations have ever done. And then there is Gaganyaan, India's first crewed spaceflight, Indian astronauts, Indian rocket, Indian soil, no borrowing a Russian vehicle, no riding as a passenger on someone else's mission. India flying its own people into space for the very first time. 60 years after that first rocket arrived at its launch site on a bicycle. 60 years after a laboratory was set up inside a church. 60 years after a tracking station was built in a public toilet. India is sending its own people to the stars. And NASA is watching, not with pity, not with condescension, but with genuine respect. So much respect, in fact, that the two organizations are now building a mission together. A joint Earth observation satellite called NISAR, combining the resources of the world's richest space agency with India's. The organization that once needed NASA's instrument just to map the Moon is now sitting at the same table as an equal. The student became the partner. So what did India actually find on the Moon? India found electricity crackling across the lunar surface, something never detected from the ground before. India found that moon soil is such a powerful insulator, it could protect future human habitats from extreme temperature swings. India found sulfur where nobody expected it, revealing new clues about how the Moon itself was born. And through the absence of water at the surface, India showed the world that the hunt must go deeper, into the coldest, darkest craters that no machine has reached yet. India did not just find facts. India handed humanity a map of what still needs to be found. And here is what the world sometimes forgets about India. India has been told over and over throughout its history what it cannot do. Colonial powers said it could not govern itself. Wealthier nations said its space program was a waste of money. Technology agreements deliberately blocked it from accessing advanced rocket engines. Every single time, India responded the same way. Not with anger, not with giving up, with work. The kind of work that sends a Mars mission on a budget smaller than a Hollywood film. The kind that builds cryogenic engines from scratch when nobody will share the technology. The kind that crashes once, learns, rebuilds, and lands perfectly the second time. Because of that work, India's lander now sits silently on the Moon's South Pole. Long after everyone alive today is gone, long after nations and rivalries and competitions have faded, Vikram will still be there, in the dust, in the silence. Proof that a country that once carried its rocket on a bicycle flew that same dream all the way to the Moon. So the next time someone asks what India is capable of, what do you think the answer should be?